Hello students, welcome to the math class. Today we are going to discuss about the chapter 13, that is surface areas and volumes. Before going to surface areas and volumes, we should revise something about the areas first, okay? So these surface areas and volumes, these relate to the three-dimensional shapes. We know about the area of triangle, rectangle, square, parallelogram, trapezium, rhombus, circle, etc. So when we think about those surfaces, those are two-dimensional surfaces. Fine. So now whenever we look, usually we see solids, isn't it? Whenever we look, wherever we look, we see solids. So all these kind of solids, they have some areas, that means they take some space, and they have some volumes as well. So far in all our study, we have been dealing with figures that can be easily drawn on our notebook, isn't it? We can draw the two-dimensional shapes. For example, if I wish to draw a rectangle, or a triangle, a square, a parallelogram, I can very well draw all those objects on a notebook or a plane. So these all are plane figures. These all are plane figures. We have understood what rectangles, squares and circles are. What we mean by the perimeter and area and how we can find them. We have learned these in earlier classes. It would be interesting to see what happens if we cut out many of these plane figures of the same shape and size from cardboard sheet and stack them up in a vertical pile. By this process, we shall obtain some solid figures, briefly called solids, such as cuboid, a cylinder, etc. In the earlier classes, we have also learned to find the surface areas and volumes of cuboids, cubes and cylinders. We shall now learn to find the surface areas and volumes of cuboids and cylinders in details and extend this study to some other solids such as cones and spheres. So let us first discuss surface area of a cuboid and a cube. Okay? Students, as I have told that a three-dimensional surface, just like your cuboid and cube, they are made up of plane surfaces. You are given an activity in your book how to make a cuboid. So you can follow the instructions and make it by yourselves using cardboard. Here I have drawn diagrams of a cuboid and a cube, and let us find out how we can come to the conclusion for the formula of the surface area of cuboid and cube. Okay? Let us concentrate on this cuboid. So here this cuboid, see, this is also a cuboid, isn't it? What a cuboid is? A cuboid is a three-dimensional surface, okay, having rectangular surfaces. So how many surfaces are there in a cuboid? There are 6 surfaces. 1, 2, 3, 4, 5 and 6. So there are 6 surfaces, and the opposite surfaces are equal to each other. That means this surface is equal to this surface is equal to this surface, and this surface is equal to this surface. Okay? So this is a cuboid having 6 surfaces. In the same way, in this diagram, we have 6 surfaces. So let us name the vertices of this cuboid and find out what all are the surfaces. Okay? So A, B, C, D, E, F, G, H. So after naming all the vertices, so let us now find out which all rectangles are there in this cuboid. Okay, starting from the top, we have ACGH down BFED. On my left hand side ABDC, on my right hand side HFEG, back side ABFH, and front side CDEG. So in this way we have total 6 rectangles. Okay. So now for each rectangle we have some area, isn't it? So for each rectangle we have area, so it should be L into B. This is also L into B, L into B, L into B, L into B, and L into B. Fine. So the total surface area means the area, the sum of all the areas of these rectangles, isn't it? Because each rectangle is having some area, so total surface area means sum of all the areas of these rectangles. So when I add all this, okay, when I add all this, I have what? 6L plus 6B, isn't it? So 6L plus B. But remember one thing, it can only happen when all the lengths and breadths are equal, isn't it? 6 length plus breadth, we have length into breadth as area for each rectangle, but these lengths and breadths, they are not equal for each rectangle. So we cannot use this formula to find out the surface area or the total surface area of the cuboid. Though we use the formula L into B for each of the rectangle, but if we add all the formulae together to get into this formula 6 into L plus B, this will be wrong, because in each case all the rectangles have different lengths and breadths. So let us find out the actual formula using the sides of each rectangle. Okay, this is your length, breadth and height. And as we know, each surface of the cuboid is a rectangle, so the opposite sides are equal. As per that I have marked, see, this is H, that means this is also H. This is L, that means this is L. This is B, that means this is B. In that way I have marked all the sides. Now let us concentrate on each rectangle. Fine. ACGH. ACGH. What should be the area? Length into breadth. BFED. BFED. B, F, E and D. It should be length into breadth. ABDC. ABDC. It is breadth into height. HFEG. HFEG. It is breadth into height. ABFH. ABFH. It is length into height. CDEG. Again length into height. So from here you can see that when we sum up this, it is 2LB, it is 2BH and it is 2LH. So when I add all the areas, I get 2LB plus 2BH plus 2LH, that becomes 2. If I take 2 as common, LB plus BH plus LH. So this gives us the formula to find out the total surface area of a cuboid, that is 2 into length into breadth plus breadth into height plus length into height. Because it is a 3-dimensional surface, it has length, breadth and height. The formula for the total surface area comes to 2 whole into LB plus BH plus LH. Okay? Students, as we know, the unit of area is square unit. So, in this case also, the unit of the total surface area is square unit. That means, for example, if the length, breadth and height of a cuboid are 15 centimeter, 10 centimeter and 20 centimeter respectively. Okay? Length is 15 centimeter, breadth is 10 centimeter and height is 20 centimeter. Then we can find out the total surface area of the cuboid by using this formula, 2 into LB plus BH plus LH, that is 2 into 15 into 10 plus 10 into 20 plus 15 into 20, that is equal to 150 plus 200 plus 300 or 2 into 650, that gives us 1300 centimeter square. So, 1300 centimeter square is the total surface area of a cuboid having length, breadth, height as 15 centimeter, 10 centimeter and 20 centimeter respectively. Okay? In this way, we can find out the total surface area or the surface area of a cuboid. Okay? Students, we have found out the formula to find the surface area of a cuboid. Now, let us discuss what should be the formula for the surface area of a cube. Okay? So, now as I have drawn the shape, this is a cube. And what is a cube? A cube is a 3-dimensional shape in which there are 6 surfaces and each surface is a square. So, suppose each side of the cuboid is A. So, all the sides are same. Fine. So, as all the sides are same, we have 6 squares, that means each square is having area of A into A, that is A square. And as we have 6 squares in this cube, so the total surface area is equal to 6 into A square, that is 6A square. So, this is the formula for surface area of a cube. Why 6A square? Because each side is same and all the surfaces are square. Each square is having area of A square. So, 6 surfaces, that means 6 squares, and the total surface area comes to 6 into A square, that is 6A square. Hope you have clearly understood the formulae for the surface area of cuboid and cube. Okay, students, suppose out of the 6 faces of a cuboid, we only find the area of the 4 faces, leaving the bottom and top faces. In such a case, the area of these 4 faces is called the lateral surface area of the cuboid. So, lateral surface area of a cuboid of length L, breadth B and height H is equal to 2 LH plus 2 BH. 2 LH plus 2 BH, that is, when I take H as common, 2H L plus B. So, by following this formula, we can find out the lateral surface area of a cuboid. Fine. So, this is lateral surface area and that was surface area. Okay. Surface area is 2 into LB plus BH plus LH, and lateral surface area, that means the areas of 4 sides, those surround the cuboid. leaving behind the top and bottom surfaces. Okay. So, keeping in view of the above, the surface area of a cuboid or a cube is sometimes also referred to as the total surface area, as I have been referring time and again during my discussion. Okay. So, let us now solve some examples. Fine. Students, let us now discuss example 1. What it says? Mary wants to decorate her Christmas tree. She wants to place the tree on a wooden box covered with colored paper with picture of Santa Claus on it. You can see the figure that is given in your book. She must know the exact quantity of paper to buy for this purpose. If the box has length, breadth and height as 80 cm, 40 cm and 20 cm respectively, how many square sheets of paper of side 40 cm would she require? So, students, clearly it is said that the box is a cuboid. And another thing, she is going to buy square sheets of paper of side 40 cm. So, these all are the given data. Now, let us go to find out the solution for this question. Okay? Students, since Mary wants to cover the box from the outer side, let us focus on the given data, that is your length is 80 cm, breadth that is 40 cm and height it is given as 20 cm. So, the surface area of the box, let us find out the surface area. Surface area for which the formula is 2 into LB plus BH plus LH. By putting in the values of LBH, we get 2 into 80 into 40 plus 40 into 20 plus 80 into 20. That gives us surface area of 11,200 centimeter square. Now, let us find the area of each sheet of paper. Each sheet of paper is of size 40 centimeter. So, A is equal to 40 centimeter. So, area of each sheet is equal to A square, that is 40 into 40, 1600 centimeter square. Okay. So, total surface area is equal to 11,200 centimeter square and area of each sheet is equal to 1600 centimeter square. Therefore, let us find out the number of sheets required. So, number of sheets required will be total surface area divided by surface area of each sheet of paper, that is 11200 divided by 1600. 11200 centimeter square divided by 1600 centimeter square, that is 7. So, how many sheets of paper does Mary need? That implies Mary would require 7 sheets of paper. Mary would require 7 sheets of paper. Hope you understood this. Students, Let us now discuss example 2. Okay? What it says? It says Hamid has built a cubical water tank with lid for his house with each outer edge 1.5 meter long. He gets the outer surface of the tank excluding the base covered with square tiles of side 25 centimeter. You can see the figure that is given in your book, that is figure 13.5. The question asks, find how much he would spend for the tiles if the cost of the tiles is rupees 360 per dozen. So now let us go for the solution. Okay? Students, since Hamid is getting the 5 outer faces of the tank covered with tiles, he would need to know the surface area of the tank to decide on the number of tiles required. So, what are the given data? Edge of the cubical tank, edge. The edge is 1.5 meter. Fine. So, for convenience, let us convert this into centimeters. So, it is 150 centimeter. Fine. That means the side of the cube is 150 centimeter. Surface area of the tank. So, surface area is equal to 5a square, because we are going to cover 5 surfaces of the tank. So, the surface area will be 5a square, because we know, as we have already discussed, each surface of a cube having area a square. So, 5 surfaces means 5a square. So, putting the value of a, I get centimeter square. Fine. Centimeter square. So, this is the surface area of 5 surfaces to be covered with tiles. Now, let us find out the area of each tile. So, area of each tile, that is a square, where a is given as 25 centimeter. So, 25 square is equal to 625 centimeter square. So, now we have surface area of 5 surfaces and area of each tile. So, to find out the number of tiles required, we need to just divide these two areas. So, number of tiles required is equal to 112500 divided by 625. Okay, 112500 divided by 625, that gives us 180. Now, we need 180 tiles, but to find out the cost, we have to concentrate that as per the given data, cost of a dozen tile is given. That means cost of 1 dozen tiles, that is 12 tiles, is equal to rupees 360. Okay. So, how many dozens of tile we require? (180) divided by 12, 15 dozens. So, cost of 1 dozen is equal to rupees 360. So, total cost will be rupees 360 into 15. Rupees 5400. Okay. So, Hamid needs to spend rupees 5400 to purchase 15 dozens of tiles so that he can cover 5 surfaces of the tank. Okay. Hope you have understood this. Today we have discussed the concepts of surface area and lateral surface area of cuboid and cube. We have gone through some examples. In our next class, we will discuss the other questions of the exercise. Till then, revise all the concepts, practice the examples and the questions which we have discussed. Okay? Till then, keep smiling, be safe. Thank you.